What we're going to do is we're going to be solving exponential problems using logs. But before we do that, what I want to do is solve some exponentials without logs, just to remind us how we did it without logs. So for the first one, what we need is a common base. So the common base would be 2. So this would be 2 to the x. This would be 2 to the 6th. Since the bases are the same, they cancel, and we get our answer x equals 6. So notice that in order to solve it exponentially, what we need is a common base. In the same way with the next one, our common base is 3. So that's 3 to the x, and 3 squared is 9. And then we put the x minus 1 in parentheses. 3's cancel, and we get x is equal to, I'm going to distribute the 2x minus 2. I'm going to move over the 2x, so I get negative x is equal to negative 2, and x is equal to 2. And then for the last one, what we're going to do is find a common base. So that would be 2 again. So this would be 2 squared is 4. And then we have the x plus 3. And 32 is 2 to the 5th. Now, since it's a fraction, I'm going to put negative 5th. Once again, the bases are the same. So we get 2x plus 6 is equal to negative 5. I'm going to subtract the 6 and get 2x is equal to negative 11. I divide it by 2. And so x is equal to negative 11 halves. Now what we're going to do is we're going to look at exponential equations when the bases are not the same, and that's when we use logarithms. So as our example here, I divide by 2, and 12 divided by 2 is 6. I want to get rid of the base of 3, so I do the log base 3. I do it on both sides. It has to be a common base because when the bases are the same, it cancels, and we're left with the x plus 1. We have to use the change of base formula, and that's big number on top, small number on the bottom, and that's our change of base formula. We put it in the calculator as log of 6 divided by log of 3, and then we subtract the 1 to get our final answer. So with example 2, first thing that we're going to do is we're going to subtract the 3. So we get 2x is equal to 6. Then we're going to do the log base 2. We always do it with the number that is underneath the exponent. So that way it cancels and we get the x by itself. We put the big number on top. We put the small number on the bottom. If you have a scientific calculator, you want to calculate it yourself just to make sure you know how to work your calculator, and you should have the answer x is equal to 2.58. I like to do 2 decimal places, so you'll see most of my answers are that way. For the next one, I'm going to subtract the 8, and when I subtract the 8, what I get is negative 7. Then because I have 2 negatives, I'm going to divide it by negative 1 to get a positive. I want to get rid of the 2/3 in order to get the x by itself. So I'm finding the log base 2/3 on both sides. So log base 2/3. Base is the same, they cancel. We get the x by itself. I'm going to use the change of base formula, big number on top. So on your calculator, you're putting log of 7. Make sure you close a parenthesis. And then you do log of 2/3. And that right there is going to give you the answer x is equal to negative, and then I have 4.80. Once again, I'm rounding to 2 decimal places. So letter C, once again, same thing. First thing I'm going to do is add the 6, and that right there gives me 89. I'm going to divide it by 7, and when I divide it by 7, it doesn't go in evenly, but it doesn't really matter because the calculator does most of the work. So we're just leaving it as 89 over 7. I'm going to do the log base 5, and the reason that it's base 5 is because the 5 is what I'm trying to cancel, and I'm trying to get the exponent by itself because that's where the variable is. So I have x plus 3 is equal to, and then I have log of 89 divided by 7 divided by log of 5. And that right there gives me 1.58. And then I subtract the 3. And that gives me x is equal to negative 1.42. Once again, make sure you're working your calculator to see if you're doing it correctly. So for letter D, we're going to do the same thing. I'm going to add the 2. And so I get 6 to the x is equal to 14. I'm going to do the base of 6, so log base 6 on both sides. And the 6's cancel. I get the x by itself. Change a base formula, log of 14 divided by log of 6. And when we plug that into our calculator, we get 1.47. So letter E, once again, we want to get the base number by itself. That's always our first step. So we have to subtract the 4. So we get negative 3 to the negative x is equal to negative 6. Since they're both negative, I make them positive. The base number is the 3, so that's why I'm doing log base 3 on both sides. It cancels. I do change a base formula, log of 6 divided by log of 3. And when I do that, what I get is negative x. Let's see, I get negative x is equal to 1.63. And so positive x would actually equal negative 1.63. And our last one. First step, subtract the 9. Our goal is to get the base number by itself. Once again, the base number is the one that has the exponent. So when I subtract it, what I get is 14. Then I'm going to divide it by 2. So when I divide 14 by 2, what I get is 7. And then I'm going to do the log base 1/4 on both sides because that's our base number. So that's the one I want to cancel to get the x minus 2 by itself. I do change a base formula, log of 7 divided by log of 1/4. And that right there gives you negative 1.40. And when I add the 2, what I get is x is equal to 0.60.